everybody, and welcome to Build Meets World. Happy Friday, June 10th. I'm pretty excited with our guest contributor today. If you didn't recall, we are focusing in the month of June on really looking at energy efficient construction, specifically zero energy school construction, and really happy to have Ben Robertson joining me today. Ben, welcome to our Build Meets World broadcast. We met, gosh, a few months ago. I think it was actually in November. After we went through a building, there was two dorms that were built in Louisville, Kentucky, actually, with insulated concrete forms, and then we were able, Martin Clark, shout out to Martin, brought me over to visit with you, and it was a great conversation. Since then, obviously, we've had some conversations, but pretty excited to have you on the program today as our guest contributor. So why don't you go ahead and introduce yourself?
Well, thank you. I appreciate the opportunity. And you know, I knew we were going to do this today, and I'm wearing a Hawaiian shirt, so it's Hawaiian Shirt Friday at CMTA. So I went ahead and stuck with tradition and kept the Hawaiian shirt. So hopefully it doesn't offend anybody. No, I'm not in Hawaii. I am in Louisville, Kentucky. So Ben Robertson, I lead our federal group here at CMTA. All things federal. Do have a passion for high performance zero energy buildings. I came to CMTA. I used to be a client. I worked for the Army Corps of Engineers, where I got exposed to CMTA, became a fan. Now I'm here. So that's my quick summary of how I got to CMTA.
Awesome. Well, I thought maybe you were at a tiki bar. Does CMTA have tiki bars within your offices?
We probably participate in a lot of tiki bars, but we do not have one in our office. Okay. We can put that as I like your suggestion, though.
Yes, we'll send that out to your human resources as a must do. A putting green and a tiki bar is a must.
No, we do have a putting green.
I threw that in because I saw it a couple of weeks ago.
Yes, we do have one.
Work hard, play hard, right? But you know, CMTA, you know, once again, a shout out to Martin Clark for introducing me to you and to CMTA, and I am just wowed with the work that you guys do. I know you guys speak to these three pillars that represent, you know, the work you do in the industry and your impact. Do you want to talk to me about them?
Certainly. You know, we're an MEP company: mechanical, electrical, plumbing, fire protection, security, IT, commissioning. That is the service line that we offer on the engineering consulting side. But as you said, really what makes CMTA what CMTA is we specialize in high performing buildings, zero energy buildings. We view ourselves as being the leaders in this industry for cost effective, high performance zero energy buildings. We also have a performance contracting arm that does guaranteed energy savings. We understand that performance contracting can have some challenges, but our group has shown how it can be done in a very simple way that outperforms any of our competitors.
Well, and we just had a conversation about that, and I think that's what really sets you guys apart. You know, you're involved in the systems that are related to a structure, and you're really looking at that performance, and not only looking at it, helping out how to achieve it, and then monitoring it with all this wealth of data to go back and refer to say, wow, look at the impact we truly did have on performance.
That is a huge differentiator for CMTA, and that's what attracted me to CMTA years ago. We're a data-driven company. We collect data on all our projects. So we do post-occupancy measurements on how the building actually performs. So 20 years ago, when CMTA set on this path to build better buildings, they did so by tracking post-occupancy performance. How is the building actually performing in real life compared to the way we intended for it to actually perform? Early on, there was a difference. They weren't performing quite like they expected them to. So over the years, CMTA has dug into those details to understand how to get a building to perform in real life, you know, at the actual utility meter. And so we've taken that data and we inform design, and we make different decisions. When we're sitting across the table from an owner or an architect, we can help guide them down the right path because we have all this data.
Yeah, and I think that's what's so incredible. And some of the information that your colleagues shared with me is outstanding in terms of dashboards, right? That can be used in real time for your clients. And I love the fact that, you know, you got introduced with CMTA because they were someone you were working with, and then you wanted to be a part of that. So I think that really sets it apart. I know you mentioned your impact and your work with zero energy, so I wanted to include that as well. Great work here as well. Is there some highlights? We'll talk about it, of course, but anything specifically you want to bring to us right now about zero energy?
Certainly. I mean, we do view ourselves as national leaders. I mean, we are a 600-person MEP firm, 31 offices across the country. We have 9 million square feet of zero energy buildings. There's 67-ish projects that are zero energy. We have 200 projects that are considered zero energy ready. So we have been at this for a long, long time. And what I've always been most impressed with is they're all cost effective. It's not that we just spend money to make that happen. Because let's face it, anything can be zero energy if you just write a check. I mean, if you put enough solar on a roof, you can be zero energy, but that doesn't mean it's cost effective. So when CMTA says we've got 9 million square feet of zero energy, it's cost effective zero energy. And I think that's a huge, important detail. Because let's face it, I mean, there's only so much money. Owners only have so much money to throw at these projects. So we find ways, and we even though we're an MEP company, we get way outside of our lane. I mean, we get into envelope and orientation, the percent of glazing to envelope. We look at floor to floor heights, how much square footage does the mechanical system take up. I mean, we're all about cost shifting so we can afford to buy better systems that perform, better envelopes. ICF is a big system type that we use all throughout the country.
That was going to be, so anyone watching right now, if you have a question for Ben, don't forget to use your question pane there to type that in, and Ben, I will vet through them for you, so you don't have to worry about that. But that is, I think, a really important question, about focusing on, zero energy ready, but also making it cost effective. I think that's huge, right? Because I think people think, oh, it's unattainable for me. I have to do things that I can't afford to do. And in many ways, we should look at it as we can't afford not to do it.
I mean, that is a conversation we have on every project. I mean, everybody is concerned about cost. Everyone has a perception that zero energy is not attainable, that we don't have the budget for it, et cetera. And don't get me wrong, there are projects where that may be a challenge, but we always start with what is it going to take to make this project zero energy? How can we accomplish that? And if we can't make it full zero energy, let's at least make it zero energy ready. Let's at least set us up for success in the future.
Do you want to? Somebody just asked that the description between zero energy and zero energy ready.
Okay. So zero. First of all, I'm going to start with cost-effective zero energy. Okay. So cost-effective zero energy means that we're going to optimize every system we possibly can to lower the energy consumption to as low as we can get that. So we measure something called EUI, energy use intensity. It's how much energy a building consumes on a square foot basis per year. So think of it like miles per gallon in your car. In a car, you want the highest numbers you can get, as many miles as you can drive, on a tank of gas. On a building, you want a low number. So an EUI, the lowest number you can get, indicates how much energy that building consumes per square foot per year. So our goal is to lower that as low as we can get it before offsetting with renewables. So we've got schools that are performing as low as 13 EUI. So the lower that number, the smaller the PV array has to be to offset that energy. And so when I say zero energy ready, Department of Energy has kind of defined that as 35 EUI or lower. Anything so 35 EUI, that is considered cost effective to be zero energy. And so projects that we say are zero energy ready means they're 35 EUI or lower. but they don't have the PV on the roof or on the site to offset that energy.
Got it.
Whereas
So,
ones that are full zero energy, they already have that PV on the roof.
so they've already put the photovoltaic to work for them. So do you know what an average EUI would be?
For a school?
Yeah.
For a school in the mid 70s is a typical school across the country is operating in the 70s. Maybe, get into the 60s perhaps, but somewhere in that 60 to 70 EUI range. So when you talk about, we've got schools all the way down to 13, that's a drastic energy reduction.
Wow.
And I'll go and address this one because everybody says, well, you think we just came out of COVID, right? And everybody's concerned about indoor air quality and filtration. And
yep.
So people assume, oh, you must be cutting the air exchanges and not being code compliant. Actually, that's not the case at all. We also subscribe to WELL principles, healthy buildings, which advocates for beyond code minimum ventilation.
Okay.
So a lot of our high performance buildings actually are well beyond code minimum ventilation for indoor air quality. So, but it's a penalty. It's a balancing act.
Yeah.
You do pay a penalty for that, but we believe it's the right solution for the occupants of the building.
Well, and I think that's great. I'm glad you brought that up because once again, we're talking about cost-effective construction, getting you to that zero energy or energy goal that you have for your building, but you certainly don't want to compromise the well-being of the occupants to get there, right?
Right.
Well, speaking of well-being and health and wellness, we had a question come in. I know ICF has played a big part in your net zero path. Talk to me about that role of ICF and also what your experience has been from a health and wellness perspective relating back to the ICF as part of it.
Sure. I mean, I personally have always been an ICF fan. There's, you know as well as I do, there's many ways of solving a problem.
Yep.
ICF is not the only answer. We've got several zero energy buildings that are not ICF. We absolutely do. It can absolutely be done.
Yeah.
We have several that are ICF. Having spent as many years doing this as I have, what's apparent at this point is ICF does simplify the equation. Okay. It's a single system that's the structure, it's the insulation, it's the air barrier, it's the water resistant barrier. I mean, it's all things in one system. So when you talk about the constructability of it, it's far simpler to construct an ICF building than you are a built up wall system. I mean, sure, we have buildings that are metal stud that have various air barrier details that are on the skin of the building, and those test very, very well. But what you have to have an architect that has very good details. You have to have a general contractor that's going to police those details and enforce those details. You're going to have a series of subs that implement those details perfectly. And not that ICF can't be done poorly, because it certainly can be, but it's more forgiving. It's just way more forgiving than some of these other systems. We do a lot of building pressure tests. Our ICF buildings, we know they're going to be very tight. We're designing MEP systems for these buildings. So when we have an ICF building, we know it's going to perform. We know how to size the mechanical system because of it. We can take advantage of that thermal mass. We can take advantage of that tight envelope. When we have a different assembly, we have to have a million conversations about how tight are we going to be able to get that envelope.
Yeah.
So.
Well, and ironically, a question just came in about that. How important is that building enclosure, that building envelope, to helping you get to that net zero goal?
Well, especially when we focus on cost effective. I mean, like I said earlier, anything can be zero energy, but to be cost effective, it has to operate efficiently. And the tighter that envelope is, the more efficient it's going to operate. So it is crucial. I'll say this: when we've had zero energy projects that have been, say they didn't initially perform as well as we wanted them to perform, and say we're getting close to not being full zero energy, because that does happen on occasion where the building's not performing as well as we had wanted it to or expected it to. A lot of
Right.
times it's envelope issues. We pressure test the building and we have to find areas that we have to seal up, or
Yep.
it's not commissioned correctly, or we have duct leakage, or et cetera. There's a million things that can go wrong, but having a tight envelope is critical to an effective building. If it's leaking, I mean, we're just wasting energy literally out the envelope.
Yeah, no, absolutely. And I think that's where the data and your experience, absolutely can help us out in terms of sharing that message out there. We had a question come in where somebody was having issue with, they were building with ICF, but not everyone involved in the project team understood that you could downsize the mechanical system. Talk to me about what your experience has been with that.
That is a challenge, and I will say, traditionally speaking, across the industry, people oversize mechanical systems. I mean, that is a common practice. Not usually knowing, some just very conservative.
Yep.
We do a lot of energy modeling in this company, and energy models are one of these things, kind of garbage in, garbage out. But we've, being that we are doing predictive energy models where we're trying to get this model to represent real life, we know how to adjust the factors in these models to take into consideration that it's an ICF building. I mean, we know how to account for the air leakage rate, the thermal mass. These are things that it's tricky, but we've done enough of them at this point in our careers that we know how to do this. So it is a factor and that's why we always say we end up putting in less tonnage than most of our competitors. We've actually gone in behind other engineers that have oversized a well field, a geothermal well field, so much that we can actually put an entire building on their well field. We've had projects like that.
Oh my goodness.
So we specialize in geothermal. We've got to date 2,500 miles of geothermal in this country. We're actually installing the largest well field in the country right now. It's 640 wells, 550 foot deep at the airport. So.
That's incredible. Another question that came in was, this person in particular is looking at heading that way. They would like to start looking at, and people tend to use the net zero energy interchangeable here, but they are looking at net zero energy building in an urban environment. Anything specific that you'd recommend there? Resources, guidance, what was your experience maybe when you first started thinking about going this route?
Certainly. Urban environments are challenging because they're very densely populated. You've got buildings that are adjacent that start shading the building that you're working on. There are a lot of high-rise or multi-story buildings, so the roof area is more limited. And we have successfully done zero energy buildings in urban environments. We've done them across this country, but the first thing you have to start with a very detailed shading study. You need to see, because if you're going to want to optimize the roof area as much as you possibly can. So you need to study that roof to see where the shading is going to come in from adjacent buildings or architectural details. You need to identify that early on, because the last thing you want to do is to put rooftop equipment in that ideal solar area where it's going to shade where the solar needs to go, because you have a limited roof to begin with. So you need to optimize that, and you need to do that early on, because that's a strategy that is going to kind of drive decisions further on down the line. And that's something people wouldn't normally see, that you have to start there, but that's kind of where you need to start.
Perfect. Great advice there. I know I mentioned it briefly already, but I think it's worth mentioning again. And there were some questions around the monitoring of buildings. And I think what we said, I think it's called an energy dashboard. Do you want to talk to us about the energy dashboard and what that looks like, what that process is, and how you guys provide that?
Yeah, we can. So we started out many years ago with an energy dashboard. We started that because the industry really wasn't ready for energy dashboards. There wasn't a solution available. There is now. Industry has developed dashboards, but we've kind of evolved from dashboards. We now have a system that we call Sphere, and it's more of a curriculum integration tool. So especially when you're talking about K through 12 schools, the building that these students go to school in is a massive science experiment. I mean, there's a lot of science that's going on in this building. So Sphere is a product that helps the teachers develop curriculum around using the building as a teaching tool. So they use this building to teach thermal mass and thermal storage. How does geothermal work? How does solar PV photovoltaics work? How does solar orientation of the building affect performance? So yes, we have a dashboard that does track energy performance. I can pull one of them up if you're interested in that.
Sure. Yep. Go ahead and give you access.
Let's see how this is going to work.
It's always fun live, isn't it?
Yeah, exactly. No pressure.
Okay.
So some of this is internal. So this is our internal site that we use to launch. So Sphere dashboards. We have, so this is where we kind of house all of our dashboards. We got several of them across the country. I'll use one of these as an example. So this is Discovery. This is in the DC area. It's got a load. Nothing like doing this live.
Yeah. Well, and I love how you talked about integrating it into the curriculum, right? Like the way these buildings are built from an energy efficiency perspective, durability, I mean, all of that turns into a great learning opportunity for the students, right? So they can actually, it's a learning environment, and their building itself can help them with that, which I think is great.
Absolutely. I mean, we're not going to spend the time to dig into this. We could spend the entire discussion digging through this dashboard, but here's an example. This is a live dashboard that shows that they're currently consuming 125 kW of electricity. They're producing 296 kW for a net positive of 171 kW. So this is a currently, and this is live. And you can export this to Excel. Math teachers are doing homework assignments based on this. I mean, it's amazing how the teachers are using this curriculum. So it's, I mean, go ahead.
I can see how great this could be from a learning tool. Now, so does anyone can access this information from your website then, and anyone that's watching, if they're interested, can take a look at this?
It's hosted on the school's website. So if you knew of the school, then yes, you could launch it. We just happen to, we have it built into this is an internal site that we can launch from. So we don't have to, it just maintains the URL. But
sure. No, I love that. I think that's what's so exciting to be able to monitor it, right? So you're putting your money where your mouth is, right? In terms of being able to say, here's what we're going to propose, and then we're going to actually monitor it. And that's a significant overage, right? In terms of what they're using compared to what their output is. And I guess I'm sure it depends on time of year.
Oh yeah, it varies. Yeah.
Right.
If you sit there and watch it, it would bounce all over the place. But
yeah,
it nets out over the year as zero. So yeah, we kind of joke in our company. We have a couple of philosophies. In God we trust. All others bring data. And also, you can't manage what you don't measure. So if you don't manage or don't measure this information, how can you really improve?
Yeah, no, I think that's great. We had a couple other things that came into questioning. So it says, one of the questions was, how does a school get involved with the Sphere education program? So that would be solely from a school that you guys were involved in, or is there something that you offer outside of that from just an energy evaluation of a school?
So generally, it has been kind of a service that comes along with a school that we've designed or built.
Okay.
I think that group who manages that has presented that solution to other schools. So, I mean, I guess if a school was interested in it, that's certainly a conversation that we could have. But
Yeah.
generally, it has been part of a school we've done, like Discovery. They were interested in that. They embraced it and launched, that whole curriculum from it. It's a very collaborative process because we could go off and do this in a vacuum by ourselves, but to make it more meaningful, we really need a school to get involved. So
Yeah.
that really depends on how much time and effort they want to put into it as to how good the tool can be.
Yeah. Well, and I know that last week we had Mike Wilson on from the Warren County Schools, and he is their energy manager. So he might be a good point of reference too. And he always talks about they open up their doors all the time, all over Warren County, to let people come through and take a look at it. I guess the other thing you could do is just look on these other schools, especially the ones from Warren County, and take a look at their energy consumption and use that as an exercise. I think overall, it's definitely something intriguing. We've always talked about, if we all could see exactly how much energy we were using every time we turned a light on, maybe we wouldn't leave them on in our rooms if we had dollar signs associated with it. I tease my daughter all the time. She's 22, and if she leaves a light on, I go, "Give me $5." She's like, "Why?" I'm like, "Because I'm gonna rip it up, because who knows what we just spent leaving those lights on." But all kidding aside, I mean, as you look towards zero energy, as we look towards all these different types of energy programs that exist out there, what kind of impact do you see the ICF can play, as some final thoughts here before we close?
So, I mean, so ICF is a solution. It's not the only solution, but it is certainly a solution. And I think from a school perspective, I mean, you've got an envelope that's second to none. I mean, there's no doubt the thermal mass and the insulation value of an ICF assembly is the best you're going to get. Beyond just that, I mean, it's a reinforced concrete structure. So, the storm resistance, the resiliency that comes along with that. I mean, you're putting your children in these buildings. I mean, I would want my children to be in the safest building I possibly can. So when you start factoring in those decisions, to me, it's kind of a no-brainer on a school, but that isn't the only solution. There's other solutions. So,
well, and you touched on the durability, and that is something, once again, I think a lot of times when people choose something, they're like, okay, well, I'm going to choose it for this reason. What might I be compromising in? And you mentioned durability. We talked about thermal mass. All of those things have such a great, huge impact on the overall performance. What about your own personal home, Ben? Is there an ICF home in your future?
There is. I'm going to build a home next year. And I told my wife many years ago that if and when we ever build a house, it's going to be an ICF house, period. So yes, I am a personal fan of ICF, but so yeah.
Well, and that's what I find interesting. I'm really enjoying getting to know our Nadura colleagues, learning ICF and industry colleagues like yourself in terms of your personal experience and the impact they can make. But what I've really begun to understand is more people that are in the ICF world have homes built with ICF. And I think that, once again, the proof is right there if they're using it for their own homes. And like you said, if you're going to build a new home, that would be where it would be headed to. So very interesting, all those different benefits that come from it. So in closing today, any final words you want to share with everybody today, as it relates to zero energy modeling, anything, final thoughts here?
Well, you mentioned Warren County, and I guess I wanted to mention a little bit about Warren County. So Warren County Public Schools, that's how we started many, many years ago. And Warren County was the best performing school district in the state. And that kind of took hold. Currently, the state of Kentucky oddly enough, is probably the national leader in energy performance school for across the country. Well, funny thing is other districts started to surpass Warren County. They were no longer the leading school district. So many years ago, they got with CMTA and said, "Hey, we want to improve some of these buildings that we haven't had a chance to renovate yet." So CMTA's performance contracting arm, Energy Solutions, went and analyzed all their existing buildings that we hadn't done major renovations to or built new ground up buildings. We were able to save enough energy waste on all these buildings that we put them back in the front running seat for performance.
Wow.
And we funded an entire PV array for one of their ground up new schools, Jennings Creek. So first time ever, energy waste paid for an entire photovoltaic array for a school, making it full zero energy. So it's an incredible story. There's many stories like that with CMTA. I feel very fortunate to be able to work here. It's a great place. We have a lot of innovative engineering that goes on in this place.
Yeah.
And so if anybody's interested, please feel free to get in touch with me. And if I can't help you, I've got 600 people at my disposal that somebody
exactly. Yep, 600 people across the country with this type of data in their back pocket, you know, in order to service the needs there of these buildings. So Ben, thank you so much for being able to be a part of our broadcast today. I really look forward to working closer with you. I know we were on a call today, so I know there's a lot of projects in our future. And I love the joint goal here we both have, both of our organizations have about, you know, energy, resiliency, durability of our structures. So I really look forward to it. So everybody that's watching, stay tuned for the rest of the month when we continue on our journey talking about zero energy. We have representatives from Sherman Carter Barnhart Architects next week, and then Alliance the following week. Lots of great videos, lots of great content that we're going to continue to share. We have a panel with 3 of Ben's colleagues talking further about just what he mentioned, the energy savings that are in the millions of dollars, and how that is going to other means and methods in terms of the community and the schools themselves. And of course, we have a presentation in June as well with Tim Geegan of Alliance, talking about residential construction and really comparing those different types of construction. So our little spoof there, the 3 little pigs, why brick was no happy ending, just once again, comparing different types of construction types there. And as always, if you want to join in the conversation, please email me at mtyler@tremcoinc.com. I will connect you directly with Ben of CMTA and some of his colleagues to answer any of your additional questions. So Ben, thank you for participating today. I know there is many more where this came from in our future, so I appreciate that.
Sounds great. Thank you for the opportunity.
So much. Yep. Okay. Thanks everybody. Have a great rest of your day.